We have seen what happens when we rub the glass rod with a silk cloth. Do you remember? Yes, both the glass rod and the silk cloth become charged. And this only happens after rubbing both of them against each other. The charges are transferred between the two during the process of rubbing. And for the charges to be transferred, contact was necessary between the two. But is this contact really necessary for the charges to be transferred? Maybe not. Let's understand with the help of this device. The device that you're seeing is called an electroscope. It has this metallic ball terminal at the top which is attached to the metal rod. And these two strips of aluminium foils are hanging freely with their one end fixed to the rod. What are we planning to do in this experiment? We will transfer the charge to these metal foils. Yes, but where will this charge come from? Let's rub the glass rod with the silk cloth to get the charge. So this glass rod is charged now. Now all we need to do is touch this metal sphere with this charged glass rod and let go. What do you observe? Did you observe the metal foils getting away from each other? Okay, so let's understand this in detail. So here is what happens in the inside. When we touch the glass rod with metal sphere, the charges from the glass rod get transferred to the metal sphere. The charges then flow through the metal rod and get transferred to the two aluminium foils. Both the aluminium foils have the same charge on their surfaces. Hence, they repel each other. You see that there is no contact between the glass rod and the aluminium foils. Yet the charge is transferred. So can we say that the contact between the two objects is not necessary for the charges to get transferred from one to the other? Yes, of course. The glass rod transferred its charge to the aluminium foils through the metallic rod. And since the charge was the same on both the foils, they repelled each other. As I said earlier, this instrument is called the electroscope. It's a simple instrument that helps us detect whether an object is carrying charge or not. Yes, if you bring any charged object near the metal sphere in its neutral state, and if the two metal foils go away from each other, it means that the object is charged. However, it wouldn't tell you what kind of charge it is. Okay, so this was about charging an object. What about discharging an object? Let's see how we do that. Now, what do you think will happen if you touch the sphere? Don't worry, it won't give you any shock. In fact, you will find that the aluminium foils get back to normal position as they were before. This can be called as discharging of the foils. Yes, and any object can lose its charge in a similar manner. But why does this happen? Your body, being a good conductor, could transfer the charge to the earth. That's correct. And in physics, we name it as the earthing process. How do we define this? Well, it's simply described as the process in which a charged object transfers its charge to the earth. But why is this simple concept so important to us? It has many important applications. The most important of all is the earthing of buildings. Yes, this concept is used in the buildings that we reside in. Every building is provided with this safety in case lightning strikes it. The lightning that strikes a building can destroy it in unexpected ways. In order to protect the homes from this natural disaster, we need to provide earthing to the buildings. This will help carry this charge to the earth and keep the building safe. Now that we've understood what electric charges are, we can get the basic understanding of why lightning occurs. We will see that in the next video.